Hello, welcome to the channel. This is the second question in Daily Dose series. We are making a series for KSET November 2024 examination, which is coming very soon. And in this perspective, we are discussing questions from KSET January 2024, especially physical chemistry questions. Organic as well as inorganic questions, they have been discussed completely. January 2024 KSET questions. If you are new to the channel, you can just think of searching for those videos and you can watch those videos too. Now in this question we will be taking a question from KSET January 2024. The question, it is based on calculation of molar extinction coefficient. Before we move on to the question, if you want to have a look at chapter wise as well as topic wise sorted KSET previous year questions with detailed solutions, you can think of referring these books. If you want to get your copies, you can just note this number and you can contact this number or WhatsApp, and the books you can receive it through courier. Thank you. Coming to the question. Question reads, using cuvettes of 0.5 cm path length, a 10⁻⁻⁴ molar solution of a chromophore shows 50% transmittance at certain wavelength. The molar extinction coefficient of the chromophore at this wavelength is, and they have given the value of log 2. So first let's try to understand the question. So what they say is that they have a cuvette of 0.5 cm path length and they have taken a solution whose concentration is 10⁻⁻⁴ molar. In UV absorption spectrum, usually we use this kind of cuvettes, and solution it will be taken inside the cuvette, and this will be kept in the instrument, UV absorption instrument, where UV radiation, or for that matter visible radiation, it will be made to fall on the cuvette and from the other side it will pass out. So the intensity of the incident radiation in such case, it can be denoted as I0, and this chromophore, whatever solution it is present here, some chemical constituent that will be capable of absorbing the incident radiation of a particular wavelength. Once it absorbs it, it will transmit the remaining light, and the intensity of that remaining light, it can be referred to as simply I. Usually it will be simply referred to as I, or for clarity sake you can refer it as IT. I0 is intensity of incident radiation, whereas IT is the intensity of transmitted radiation, right? So when this process happens, whatever the amount of light this solution it has absorbed, it can be called as absorbance. But mathematically, what is absorbance? That is actually given by Beer-Lambert's law. You might be familiar with this law. What this says is that absorption, mathematical definition of this absorption is log of I0 upon IT, where I0 and IT, they are incident radiation as well as the transmitted radiation intensities. That will be equal to C epsilon L. C is concentration of this solution. Usually it will be taken in terms of molar concentration. Length, usually it will be taken in terms of centimeter. That's what they have given, 0.5 centimeter here. And this epsilon, it is actually property of the chromophore. Epsilon, we cannot change it. It is actually the property of the chromophore that is inherent for the given chromophore or for given molecule. That itself is called as molar extinction coefficient. So absorption, it is not only dependent on concentration and path length. Of course, when we increase these two things, the absorption increases, but there is something which is very, very important, which decides the absorption, that is epsilon. It is molar extinction coefficient, property of the molecule. Some molecules, they will be having very high value of molar extinction coefficient. In that case, absorption, it will be very high. And some other chromophores, for some other wavelengths, we can expect the molar extinction coefficient, which depends on the property of the molecule, to be low. In such scenario, the absorption, it naturally happens to be low. Even if you increase the concentration and length, then sufficient absorption we may not get. So now in this question, they are asking us to calculate this particular value, epsilon, molar extinction coefficient, and that can be calculated simply from this equation itself. So if I just rearrange this equation, epsilon, I can say that this epsilon I keep it here and just think that C and L I am bringing it here. So epsilon it will be is equal to log of I naught upon IT. This I have kept it as it is, and these two things, if I bring it to the other side, it will be 1 over concentration and length. Right? Now concentration it is readily given. They have given that it is 10 raised to minus 4 molar, no problem with that. Length it is given to be 0.5 centimeter, and no need to change the units of this, they are in appropriate units itself. If you just look at the answers, final answers, they are per molar per centimeter. So epsilon, now this I naught and IT units, they'll mutually cancel out, and epsilon unit it will be per concentration per length, so that will be say per molar and per centimeter. So that is readily there. So no need to change the units of this path length as well as concentration. Now just we need to find out this value, log I naught upon IT. If we know this value, easily we can find out epsilon. To find out the value of this log of I naught upon IT, which is nothing but absorbance, they have given us the hint that they say in the question, the chromophore shows 50% transmittance. From this 50% transmittance, we can calculate this log of I naught upon IT, which is nothing but absorption. So how we can do that? For that we should know what is transmittance. Transmittance, it is simply IT upon I naught. Remember here, very important thing, you may go wrong here. Transmittance, it's not a logarithmic quantity, it is straight away IT upon I naught. Whereas absorbance, it is logarithmic quantity, it is log of I naught upon IT. Again here you should not confuse with the I naught and IT. If you just write absorbance as IT upon I naught, log of IT upon I naught, you may go wrong. When it comes to absorbance, it is log of I naught upon IT, whereas transmittance, no logarithm, straight away it is IT upon I naught. So this is given to be 50%. Here they have given. So 50%, it means IT, it will be 50, and I naught you can take it as 100. So this is how we can represent 50%. So that comes to 1 by 2. So now if IT upon I naught it is 1 by 2, what we need here is I naught upon IT. I naught upon IT, that will be simply reciprocal of this, which will be equal to 2. So indirectly they have given us the value of I naught upon IT in the form of transmittance, which is IT upon I naught. From transmittance we can calculate this I naught upon IT to be 2. So now if I substitute all the values here, this will be log of 2, and log 2 value readily they have given here. Otherwise also it is expected that you should know the logarithm of 1, 2, 3, 4, 5. Sometimes they'll be very useful. Anyhow, luckily in this question it has been given. So log 2, you can just substitute that. Concentration value, it is 10 raised to minus 4 molar, substituted. Path length, it is 0.5 centimeter. Just have not written the units, but they are substituted appropriately. Now log 2, it is 0.301. Simply I just simplify this. 10 raised to minus 4, if I take it to the numerator, it will become 10 raised to 4. 0.5, which is nothing but 1 by 2. If I take it to the numerator, it will simply 2. Now if I further simplify this, this will be 0.301 into 2, which will be 0.602 into 10 raised to 4, which is nothing but 6020 value. And as I mentioned earlier, concentration unit, it is molar, so it is in denominator. So per molar. Length unit, it is centimeter, 0.5 they had mentioned. So it's in numerator, so it's in denominator. So that's how it will also be centimeter inverse. And now you can easily find that 6020 per molar per centimeter as one of the answer. And that's how D is the correct answer for this question. If you are new to the channel, please think of considering subscribing to the channel. And you can press the bell button to get the notifications of new videos. You can forward this video to your friends. Thank you for watching this video. Thank you again.